Hello guys, welcome to the machine design world. This is Keval Patil and today we are going to see design of bolted joint which are eccentrically loaded using PSG design data book. Let's move to the design of bolted joint. You will find the dimensions of bolted joint on PSG page number 5.42. Alright, now we will see the construction of bolt. Before going to the design, we should know all the parameters. Okay, so first thing is this is bolt head. This part where there is no threads, we call it as a shank, and threaded parts is know that threads. Simple, there are threads. Okay, so this is internal diameter or inside diameter of thread, we call it as DC. D is a nominal diameter or outside diameter of thread. L is a length of the thread or thread length. Okay, so this is a basic parameters which we're going to see in bolted joint. D called as nominal dia or outside diameter of thread. DC core dia or inside diameter of the thread. L thread length. Okay, length of the thread. Now the heading is eccentrically loaded bolted joint. So what we have here, what is eccentrically loaded? So let's guess this is the axis. This is the axis of something or something bolt axis, and load is somewhere out. It is not on axial. It is not on axis. Then we will call it as eccentric load. There is eccentricity present between the axis of the part and load. Okay, so if we are having some component like this, okay, and this is the axis, okay, and load is acting over here, load is acting at this corner, then this will be the eccentricity. This will be the eccentricity. If it is on axis, then we will call it axial load. Okay, now if it is acting at eccentricity E, then it is eccentrically loaded. So in our design process, the bolts will be eccentrically loaded, means there will be eccentricity at the line of action of load and the bolt axis. We having three cases. Okay, so first case is bolt axis in the plane of load. Second case is eccentric load perpendicular to the axis of bolt, and eccentric load parallel to the axis of load. The first case I'm just naming it shear. Okay, it is direct shear and torsional shear, just naming it. Okay, and this second case I'm naming it shear tension, and third case is tension. Okay, these three cases are for bolted joint or design of bolted joint which are eccentrically loaded. Now we will go for the first case, that is bolt axis in the plane of load, and the which load going to act shear. We will see how these loads are acting. So case first, shear. We having a plate which is bolted to another plate or any platform or any component. Okay, and it is carrying 1 2 3 4 bolt. So bolted axis is like this. Okay, and we having force F which is acting at eccentricity E. Force F which is acting at eccentricity E. Alright, now this G is center of gravity, so it is a center of gravity of 4 bolts. Now distance of first bolt from the center of gravity we will call it as R1, radius 1, and this we call R2, R3, R4. Alright, so E is eccentricity, and I said it is shear case, means two shear load going to shear stresses are going to act on the each bolt. Now first shear stresses we call it as primary shear load. What is primary shear load? What we will do, we will just remove this load. We will remove this load and we will keep it at center. Okay, we will remove this load and we will keep at center. Then every bolt will carry equal amount of load. How? So let's guess. These are the plates. Okay, these plates, and this is the bolt. Okay, this is a bolt. Okay, this is a bolt. Now what this plate is, this plate is this plate. Okay, and this plate which is carrying a load, which is carrying a load. Now this plate is fixed, this plate is fixed, and this plate you are just pulling it down. So what will happen, this bolt will break from here, this bolt will break from here. This is the axis of bolt. Okay, now I'm watching these plates from this side. Okay, from side left hand side or right hand side, you will see this bolt. So see, bolt is like this, bolt is like this, and I'm not watching from left or right side, then you will get this view. Okay, now it will break like this. This is the axis of bolt, and this is the line of action of load. It is perpendicular, it is shear load. Okay, or you can say this is a failure area, both are the parallel, then it is shear load. Okay, so we call it as primary shear load. Now I already said we remove this load and we keep it on CG. Now how much amount of this force will be carried by 1 2 3 4 bolt? We having 4 bolt, we having 4 bolt, and we having only one force which is acting at center CG. So if this value is 100, then how much load will be carried by individual bolt? That is 100 divided by number of bolt. So we are having 4, so 100 divided by 4, so 25. It is carrying 25, it is also carrying 25, it is also carrying 25, and it is also carrying 25. If it is 400, then 100 100 100 100. So primary shear load will be distributed equally among the number of bolts. Okay, so see, we having 4 bolts. I'm just mentioning this is first bolt. Okay, this is first bolt, this is second bolt, this is third bolt, and this is fourth bolt. So primary shear load which is acting downwards, all right, primary shear load is acting downwards. So primary shear load, I'm saying on bolt 1, so we are saying FP is a primary shear load, Fs is secondary shear load. So Fp on bolt 1 is primary shear load on bolt 1 is equal to Fp2 is equal to Fp3 is equal to Fp4, because these loads are same, equally distributed, is equal to F divided by number of bolts, that is 4. So I'm just saying F divided by N. Okay, or you can say is equal to F divided by N. Alright, now this is Fp1, Fp2, Fp3 and Fp4. Okay, so you understood primary shear load, then we will go to the secondary shear load. Okay, secondary shear load. So what is secondary shear load? To understand this, we will use the torsion formula, that is tau upon R is equal to J upon T upon J. Okay, so this formula, I think you have seen that simple torsion. Okay, torsion formula. So torque is nothing but T upon J into R. This is shear stress, sorry, this shear stress, this is torque, this is polar moment of inertia, and this is radius. Okay, so now I'm saying tau is equal to T upon J into R. Now see, this torque and J, torque is constant because it is a force into radius, so it is a constant. Okay, then J is or we can say that torque is a function, shear stress is a function of R. Shear stress is a function of R. Okay, so from this equation we can say that shear stress is function of R. Now what is shear stress? Shear stress is nothing but shear force upon shear area, or we can say resistive shear force upon area on which shear stress is acting. Okay, then it is proportional to radius. Now Fs is proportional to A here, so A into. Now can I say this area is constant, area is not going to change, So Fs is proportional to R. So Fs is proportional to R. So secondary shear load is proportional to R. Now if I am removing this proportionality, then I have to add proportionality constant. So I am saying Fs is equal to constant into R. So this is my first question. Okay. Now how this shear or secondary shear load will act? This secondary shear load will act like it is moving like this. It is moving like this because of this force. It is going to rotate like this. It is going to rotate like this. So whatever so when this whole plate will try to rotate like this, it will try to rotate this bolt. This bolt, it is not like, it is actually screw, but I am considering it's bolt. Okay, so when this bolt is in this position, you are applying load over here, so it will try to rotate. It will try to rotate this bolt. So we can say it is rotating. Then if it is rotating, then shear stress is acting, or we can say torque is acting, and torque is nothing but shear stress. Because of torque, which stress is going to act? Shear stress. Okay, so we will call it as secondary shear load. Now how it is going to act on 1, 2, 3 and 4 bolt? It will act, this is radius, then it will act perpendicular to the radius and in the direction of the load. It will act perpendicular to the radius, so perpendicular to the radius and in the direction of load. Perpendicular to the radius and in the direction of load. Perpendicular to the radius, direction of load. Again perpendicular to the radius and in the direction of. So it is going to rotate like this. So perpendicular, 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 and I'm naming it Fs1, secondary shear load on bolt 1, secondary shear load on bolt 2, secondary shear load on bolt 3, secondary shear load on bolt 4. Okay, now see, we are having these loads. Now the question is, which bolt is carrying highest value of load? Which bolt is carrying highest value of load? Now see, if our primary load is downward, now I'm just taking two components of this load. It is having something angle theta between this. This angle theta is nothing but this angle theta. This theta and theta will be same. This theta and this theta will be same. Okay, this theta will be same. Okay, so now see, if I want to take the component of this force, the first component will act in this direction and second component will act in downward direction. Similarly, for this force, first component will be in this direction and second component is downward direction. For this, it will be first component, this second component. For this, first component, second component. Okay, so this is horizontal force. I'm not considering that force. I'm just considering this vertical forces. Okay, because this vertical two forces going to add in each other. Okay, so this will be Fp1 plus this component. In this, Fp2 plus this component. For this bolt, it will be Fp3 minus this component, and here also Fp4 minus this component. So where the highest amount of load is acting? On bolt 1 and on bolt 4. So I'm just naming them. On bolt 1, this is bolt 1, this is bolt 2, this is bolt 3 and this is bolt 4. Okay, so what is the resultant force? For the resultant force, so it will be like something this and this, and you will get resultant over here. Okay, for this you will get resultant like this. For this you will get resultant like this. For this you will get resultant like this. Okay, now see, so I'm just naming it resultant 1, resultant 2, resultant on bolt 3, resultant on bolt 4. Okay, now I'm making it. Okay, so we having resultant 1, 2, 3, 4, and which resultant is the highest? R1 and R2. Because this angle will be same, both angles are same, so this resultant 1, resultant 2 will be same. Now we will go for the further derivation to find out the value of this Fs1, Fs2, Fs3 and Fs4. Okay, so to find the value of resultant shear stress, we have to find first moment due to force P. Okay, so this F is causing one moment. Okay, what will be that moment? It will be nothing but F into E. Okay, so it will be F into E. Similarly, total moment caused, or total moment of secondary shear loads is equal to, now I want to find total moment of this secondary shear load. So Fs1 causing moment at CG, that is Fs1 into R1, Fs2 causing Fs2 into R2, this moment, Fs3 is Fs3 into R3, Fs4 into Fs4 into R4. Now I can say that for a primary shear stress, I said this F will be equal to Fp1 plus Fp2 plus Fp3 plus Fp4. Okay, or it is equally divided. So now for secondary shear load, I can say that this moment, which is F into E, is nothing but Fs1 R1, that is moment due to shear load 1 plus moment due to shear load 2 plus moment due to shear load 3 plus moment due to shear load 4. So what will be the total moment? That is nothing but Fs1 R1 plus Fs2 R2 plus Fs3 R3 plus Fs4 R4. Okay, now can I say this is equal to this, because this is the effect of force F, and this Fs1, Fs2, Fs3, Fs4 is nothing but effect of force F only. So Fe is equal to Fs1 R1 plus Fs2 R2 plus Fs3 R3 plus Fs4 R4. Now from equation 1, that is this which we have derived, Fs is equal to C into R. Okay, so from equation 1, Fs is equal to C into R. Now can I say Fs1 is equal to C into R1? Similarly, Fs2 is equal to C into R2. Constant C1, C2, C3 same. C is equal to C1, C2, C3, C4 same. So I'm just writing F into E is equal to Fs1 means nothing but C R1 into R1, that is C R1 square plus C R2 square plus C R3 square plus C R4 square, because Fs1 is nothing but C into R1. So C into R1 is C R1 square. Now I'm taking this C common, so I will get R1 square plus R2 square plus R3 square plus R4 square is equal to Fe. I want to find the value of F. Okay, so how I can find? Okay, so what is value of C? C is equal to Fe whole divided by R1 square plus R2 square plus R3 square plus R4 square. Right, now I am putting this value of C in equation 1 again. So putting value of C in equation 1. So I will get Fs is equal to Fer upon R1 square plus R2 square plus R3 square plus R4 square. Now eccentricity is a constant. For Fs1 it will be F1, that is F only, F is equal to F1, F E it will be R1. So if you want to find for Fs1, it will be F same, E same, the constant value is same. Okay, then r1 square plus r2 square plus r3 square plus r4 square. This is constant value, this is fe value. Okay, it is same, only you will take r1 over. For fs2 r2, for fs3 r3, fs4 r4, this value is same. Right, so we got secondary shear load for every bolt, we know primary shear load for every bolt. Now we will go for total stress. Okay, total stress which is acting on bolts. Now see, resultant load. Next step is resultant load on heavily loaded bolt. So which bolt is heavily loaded? Which bolt is heavily loaded? We have seen the bolt 1 and bolt 2 is heavily loaded. Okay, we have seen that bolt 1 and 2 are heavily loaded. So I can take any F1 or F2, whichever you want. I'm just taking F1, both having same value. So I'm just writing F1 is equal to, so this is resultant stress, so F1 is equal to F2. Now we know the addition of vectors from maths, because force and stresses are nothing but vectors. Okay, so they're having angle in between, theta. Okay, so let's get, this is F1 and this is F2. Okay, for our case it is Fp and it is Fs. So they are having angle. So from resultant force calculation using vector addition method, we can say that resultant will be under root Fp square plus Fs square plus 2 Fp Fs cos theta. Okay, so this is vector addition method. Okay, now in our case it will be F on bolt P, Fp on bolt 1, that is primary, square plus Fs1 square plus 2 Fp1 Fs1 cos theta. Okay, and this theta is nothing but angle between the two bolts, angle between the two loads. Okay, Fp1 and Fs1. Also you can find this theta from here. If you know this distance, you can find this theta. So from here you will get maximum load which is acting on bolt 2. Okay, now I want to find the dimension of bolt. Okay, so I can use so dimension. Next step is dimension of bolt. Okay, so we know the formula, tau max is equal to maximum load or F max upon area. Now tau max will be given in the question. F max, you just put the value of F2. What is area? Area is nothing but area of bolt. We're having this bolt, we're having always take minimum area of failure. So what will the minimum area here? DC. So it will be pi by 4 DC square. For bolt it is pi by 4 DC square. Okay, cross section area. Now you can find this area and you can use the PSG and directly find the bolt diameters, or from here find DC and then use one simple equation, that is D is equal to DC upon 0.8. Okay, this is equation to find D. Otherwise, or you can go over here, this is PSG page number 5.42. You can find the area. Let's guess we are having something 60. Area has 60 mm square. Then you will find, where is the 60? It is 58. So 60 is 50. The next area. Okay, so if you having 55, then you will go for 58, but if you having 60, then you will go for next area, that is 84.3. so from here you will get area value. Now let's go to the nominal dia. So this is major dia, major dia, D is equal to D, major dia for 80 it is 12 and bolt size is M12. So we can say M12 bolt is selected. It is having pitch 1.75, major dia is 12 and minor dia is 9.853. Or you can find this DC minor dia. Let's guess you having minor dia something 12 point something, 12 point something. Then next next minor dia is this 13.546. Then you can call bolt is M16. Both method you can use. Sometimes bolt size is more than this M36. You always have to use course series. We are assuming that for course series, don't go for fine series, always use course series. Okay, now if you having something your area is something 910, so you won't find this area over here. In that case, from using this you have to find DC, and using this equation you will find T. Alright, so now we can move to the problems. Actually, length of the video is increasing, so we will see the problem related to case number 1 in next video. Thank you for watching. Keep sharing, keep liking, comment if you have any query. Thank you.